out the length BC, well, first of all we need to find the length of BO, and it's just a right angle triangle. We've got the right angle triangle, 8, 6, and we're looking for the hypotenuse. So we're using Pythagoras' theorem, which is 8 squared plus 6 squared, which is 64 plus 36, which is 100. So x is the square root of 100, which equals 10. So that whole side is 10 right up there. Now how do we find BC? Well, we know that CO is 6 centimeters as well because it's a radius. Okay, so that part's 6. So all we've got is 10 to equal 6 is 4 centimeters is BC. Again, pause and work through it and unpause for the solution. Okay, we can spot a cyclic quadrilateral, we can spot the double angle rule, and we're asked to find, first of all, in A, write down the size of the angle BAD. So BAD is up here, and that is straightforward. We've got a cyclic quadrilateral there. Okay, this one in here is not cyclic because that point doesn't touch the circumference. Now, opposite angles of a cyclic quadrilateral add to 180, so op at A is 50, opposite of 30. So that's 50 degrees. From that, we have to find ODC. Now, ODC is in here. Now, there's a couple of things we're going to have to do first before we get to there. The angle at the centre is double the angle at the circumference if it starts and finishes at the same point on the arc, and it does. So we know in here is 100 degrees. We also know that they are both radius, so they're equal. So now we've got where we can split into two triangles, and they're both isosceles. So inside this top triangle, the top angle is 100, so the two bottom angles are equal and they add to 180, so they must be 40 degrees each. So that's 40 and 40. And at the bottom, we've got 130 degrees at the top, so the bottom two angles add to 50, so there must be 25 each. 25 and 25. So the whole angle, ODC, is what we're looking for. O to D to C is 40 plus 25, which is 65 degrees. Okay, so that's using the number of the rules together. Again, pause and work out X and Y. Okay, X straightforward, starts and finishes at the same point. One goes to the circumference, one goes to the centre. The one at the centre is double. So the one at the centre is 140 degrees. Okay, and also the cyclic quadrilateral, opposite angles equal to 180. So that's 110 degrees opposite 70. Do not do it at opposite 140. It's not cyclical because it's not that vertex isn't on the circumference. Okay, so that one was straightforward. Next one, work out the size of the angle AOD and the angle ABC. So pause and work through that and unpause for the solution. Okay, we know that DAO is 90 degrees because tangents and radius meet at 90 degrees. So then we can work out the angle up at O because angles in a triangle add to 180. So we've got 90 and 36 added here, so that gives you 126, and 180 take away 126 is 54 degrees. Okay. Now, to spot the angle, that's AOD, and to find ABC, well, ABC is just rule 2. Might be hard to spot because it's slightly to the left of it, but we start at A and finish at C, and we hit the centre. We start at A and finish at C and hit the circumference. So the one at the circumference is half the one at the centre, so it's 27 degrees up there, and that's rule 2. Again, pause this one and work out A and B. Unpause for the solution. Okay, this one uses the alternate segment theorem, which is the very last rule. So we're asked to find the size of angle ABD. Well, first of all, ABD, well, the second part uses alternate segment theorem. The first part is just the radius and tangent meet at 90 degrees. Well, if we know that that's 35, well then the rest of this is 90 minus 35. So ABD, ABD is 55 degrees. Find the angle DEB. The angle DEB is here, okay? And with alternate segment theorem, the angle between the chord and the tangent is equal to the interior opposite angle. So jump inside and go up the line. So it's 55 degrees. Straightforward. Okay. You could have worked out that that was 90 using the tangent and radius rule, and then added 1935 and took that away and still found 55, and then done it the same way. Again, pause and work out this one and pause for the solution. Again, we've got alternate segment theorem, the last rule. So 58, it's opposite the interior opposite angle. So don't worry about this line yet. So that's the interior angle and up the line. So up here, I'll just rub this out, up here is 58 degrees as well. That means that the bottom two angles of this triangle are equal because we're showing it's an isosceles triangle. So these two bottom angles are the same, that entire angle at PTO. So we've got 180, take away 58 is 122, and half that, so they're both 61 in there. So 61 is the total angle. Now we're only asked to find OTQ. That's OTQ, so only this section of it. Now we know this whole angle is 61, but we also know that this angle here is 90 degrees. So we can find in here. Okay. So we've got 58 plus 61 is equal to 119, and we know that angles on a straight line add to 180. So 180 take away 119 out here is 61 degrees as well. You could have got that from alternate segment theorem because here would be the same as up here, jumping across. Okay. So now we know that this angle is 90 degrees. So if it's 61 on the outside, to find this wee bit in here, it's 90, take away 61, which is 29 degrees. So there's a lot in that one. Again, pause and work out DEF. This one's very straightforward. DEF is just the double angle rule at the centre is double the angle at the circumference. So that's 65 degrees. And given the reason for your answer. This one here, again pause. Okay, you've got the angle at the centre is double the angle at the circumference, so it's simply 170. And again, stay in your rule. And the last one, pause this and work through and find x. Okay, so we've got tangents and radius meet at 90 degrees. So we can work out this top angle because angles in a triangle add to 180. So 90 and 32 is 122. Take it away from 180. So up here is 58 degrees. Now we know angles in a straight line also add to 180. So 180 take away 58. So in here is 122 degrees. And we know that this is an isosceles triangle because OS and OT are radius. So we know the bottom two angles are equal. So 180 take away 122 is 58, and 58 divided by 2 is 29 degrees. So in there is 29 and in there is 29. So that's what x is, 29 degrees. Okay, so get used to using 3 or 4 of the rules in succession. Always look and see if you can spot tangents outside. It's the tangent radius is 90, or 2 tangents are equal, and you can draw the cate and split into isosceles triangles. You're always working with isosceles triangles. And the double rule, double angle rule, when it gets tricky sometimes, like when it's outside, like this one, that 54 is slightly to the left of it, but it's still the double angle rule. So once you learn all 8 rules, you'll be able to apply them, and more practice, you'll be able to spot them as you go through questions, and it'll be second nature to you. Okay.